Here then is the formal statement of the chain rule. If y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then we have a composition here. Y equals f composed with g of x is a differentiable function of x, and here it is in Leibniz notation. We have the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, let's recap here. It is the derivative of y, and that's the f of u function, with respect to the interior function, which is u, multiplied times the derivative of the interior function, which is the u of x function, with respect to x. Let's look at this in prime notation, just like we did in our little investigation. So the derivative with respect to x of f composed with g of x is equal to f prime composed with g of x multiplied times g prime of x. That is the derivative of the exterior function with respect to the interior function multiplied times the derivative of the interior function. Let's see how it is that we would actually set about proving this thing using the limit definition, right? So on example 1, let h of x equal the composition f composed with g of x. Show that the derivative with respect to x of h of x is equal to, as we've said, f prime composed with g of x times g prime of x. Okay, so this particular rule is proven using the alternate form of the derivative. Alternate form, alt. Doop. And then what does the alternate form look like? Here, let me just remind you that, let's say that we have a derivative, or a function. We're going to take its derivative. It should be equal to, well, actually, I don't take it at x. I take it at some value of x, which I will call, how about a? Yeah, I'll call it a. So h prime of a is equal to the limit as, and instead of as h goes to 0, we're not going to have any h's in here. It'd be totally confusing anyway because the function is called h. It says x approaches a of h of x minus h of a over x minus a. And since a is just any value of x, whenever I'm done with this one, I'm going to have the derivative, the general derivative, okay? All right, so let's just plug our stuff in to our derivative form here and see what we get. We got the limit as x goes to a of h of x is, of course, the composition minus the same exact composition with a stuck into it. So, f composed with g of a over, and then x minus a. There's nothing to do there. Okay, so if you were to stick in a for your x, you would have a good old-fashioned 0 over 0. It's an indeterminate form, and then we have to fix it in some kind of way. In order to fix this one, I don't have enough room right here, so I'm just going to move this down just a little bit right there. Maybe a little bit more. Maybe a little bit more. More? Okay, that's good. All right. So in the past, whenever we were doing the one for the product rule and the quotient rule, we had to do some sort of trick to fix that indeterminate form, and it was maybe adding and subtracting some sort of fancy 0. Now, one of the other things that we could do, of course, is multiply by a fancy 1, and that's exactly what we're going to do here. And here is the fancy 1 that we are going to multiply by. Fancy 1 is going to be g of x minus g of a over g of x minus g of a. Again, a fancy 1. And now what I'm going to do is I'm just going to switch the denominators out right there. I'm going to switch those two out. And when I do, oh, it puts a smile on this limit for sure. Limit as x goes to a of f, what a funky looking f, composed with g of x minus f composed with g of a over g of x minus g of a. And maybe it doesn't look like we did anything, but we did. It's very significant. And then we're going to multiply that by g of x minus g of a over x minus a. Okay, now I think that the easier part to recognize is the second part. That if I take the limit as x approaches a of g of x minus g of a over x minus a, that is the alternate form of the derivative of g of x at x equals a. In other words, that part is just g prime of a. Okay, now let's look at this first part here. This is doing the same thing. Maybe if I just kind of rewrite this a little bit, maybe mentally right here, this is the input right here, right? So this is like an f of x minus f of a over x minus a. This is in the place of our x, and this is in the place of our a. This is the derivative of f of x with respect to specifically this g of a that's right in here. So this is, f prime composed with g of g, no, try that again, g of a. And there you have it. We have proven using the limit definition, the alternate form of the limit definition, the chain rule.